Okay. What is missing? Butter? Oh, okay. I was traveling from Seoul, so it's late. 10 minutes already. So, do you know where we stopped last time? $13. Right. Any questions? No question? So, GM found that most of profit coming from, not from their main job of manufacturing. They found that they have more profit coming from after sales market. So they changed their focus to the after sales market, including after service and leasing and financing. So they established a financing company too. So now big manufacturing companies are having their own financial company. Hyundai Motors too, GE too. And we call this is a smart service. I'm trying to show you a rental business. It's an audio or electronic rental business market, online market. So that this may include a smart service or the part of manufacturing company rather than a separate unit. And tire rental is popular also in Korea. You don't need to buy, you just rent. So pay by months or pay by kilometer sometimes. And they have a regular checking program so that you can be maybe more safer. And also the performance can be higher than your own tire. That is the idea. From a rental company or manufacturer, also benefit to the customer. You may pay a little bit more, right? But you should trade between performance and also money. And there are many old traditional rental companies, right? But now the automakers is moving into this market too. Another benefit to automaker is that they can collect operational data, big data. That is also very important for their new design and also their improvement in engineering. Otherwise, it's not easy to collect information from car. See, I showed you my speedometer. Right? I don't want to let other people see my record, right? But if you rent a car and they promise to give you a best performance and check well before the break or problem is happening, then you may give them information. So, this is another look. Actually, this one is provided to the LG Electronics months ago. This is a rice farming field, but it is a mountainside, so that they call this is normal. It is rainfall dependent rice farm. Means you don't have a dam, so that if something wrong with the rainfall, then you should give up your whole year planting, right? So I told them that your business is similar to this LG Electronics because they are Korea also heavily dependent on export business. We export many factory manufacturing product and then import most of the raw material, including energy. Right? So we try to balance them. Right? But the problem is if there is no order, right? Sometimes it happens. Sometimes in say world economic crisis in 10 years ago, the Lehman Brothers collapse 10 years ago, right? Then all the economy goes down, and then outside export amount is going 30% to 40% down. So it looks similar to this business. So you need to have your own demand or buying market or buying power. So I recommend to LG that you need to have this kind of business too, to create your own, not so big, but at least some small portion of twofold. One is for creating demand is one side, but the other one is also collecting operational data to improve your product design. So operational big data. Is it coming from what? A shipbuilding. Oh, is it shipbuilding? It's a ship, right? It's a ship. Big ship. Probably, I guess it's an oil tanker. Crude oil tanker. I know well about the ship types. When I see the image, then I can find out which type is. This is a pipe that can load and unload the crude oils. Right, and then what happens? Right. So when the ship is operating, there are so many information is gathered, especially for the captain there. Captain should knows what happens inside the ship, right? Including steering. Steering is going directions and navigation together, right? And condition of what? Condition of engine or condition of cargo, condition of weather. There are so many conditions, right? So engine condition. And those information can be sent to storage inside onboard hard disk of speed, direction, course keeping, and engine load. Rudder angle also related with the steering, and storage and analysis. You can have a big data there, and then it can be sent to the main office in headquarters, far away, through the telecommunication. And then the owner of the ship or cargo owner, they may have a big decision. Right? Can we have a meeting together to have an important decision so that they may send the personnel, engineers to correct that problems sometimes. Right? But this ship business has been more than 500 years, including Columbus days. Right? But what happened now? The change is only this one, storage. For the last 500 years, there was information of these conditions, but it was not stored because it was analog signals. Now it converted to digital signal and then stored in the database, and then you can do many things. You can send to the landside headquarters. You can do your own analysis there. So we call this is operational big data is important. So you need to collect this one. And the technology behind this is sensors, right? Here is the sensors. Sensors detect information from the devices, operating devices. And then it is converted into digital signal and then also send it through the internet, right? Wireless internet. That is the key component now, right? Before, say, 30 years ago, there was no such device there. So there is analog devices, 100 years, information was there, sensors also there, but it was not converted into. And then the other things are new applications based on this big data. So we call this as edge computing and edge analytics. Questions? No questions. All right, and then I'm moving on to the modular, the main topic. Right? Air conditioning, right? Air conditioner. Right? So this part is indoor part, indoor module, indoor. This is outdoor module, right? But this one should be one package, one manufacturing product coming from LG Electronics probably, or GE, I don't know. But it's a natural separation of module, natural separation of module. You can expect also similar situation in a car, any car, not any car. Most of car has air conditioning system now, right? Heating and air conditioning, cooling. They also have this separation of indoor module and outdoor module. Where is the outdoor module? In a car? Where is the outdoor module? Huh?
From here there is a little bit of dripping of water.
Dripping water? Right.
Yeah.
So where is it?
Inside the hood.
Inside hood, right. And near the engine, right? But in front of engine. Why? Because you need more air to cool down, right? There is a radiator grill at the front of the car. Right? This one, radiator grill. Right? This one. Right. So it's a module. Right? What is module then? Oh, this is also inside module and outside module. Samsung and also, right? And more outside modules, right? Air conditioning. Many. When I was traveling at Hong Kong, old buildings, all room has their own outdoor modules. Very similar to this. Very interesting to me. Because Hong Kong is hot place. And old buildings, they don't have embedded modules. For modern apartment, they don't see such a things, right? Because they want to have a hiding and a bigger outdoor module, integrated one. But in old buildings, it is installed later after the building is constructed. So a modular product. In LG Electronics, they are proud of modular washer system. And I found most of the big product manufacturers, big products, including car, ship, nuclear plant, airplane, construction industry, and also even to the software industry also using a modular concept. And myself is working on standard, ISO standard, we are also talking about modular standards. Right? So modular is popular. Modular is popular. Now, I explained about personalized production, right? Not mass production, personalized production. And also I talked about smart service. And then what can be the relationship with the modular product? Modular product and personalized production, is it good or bad? Modular concept is good for personalized production and also good for smart service, or bad to them? Probably because they are moving on to the modular business, probably they are supporting this concept. Right? We'll see that. And also parts life industry. Because outsourcing, you need more purchase of parts from the outside. Right? A car, we usually call how many parts inside a car? 20,000. There's a traditional numbering. Right? But as I explained more on this, is it 20,000 is correct? Right. Inside one car, how many motors are used? Electric motors. How many electric motors? Guess. Mutar, what is your guess?
100.
100. 50? Oh, it's a big numbers, eh? 100. Only one? Electric motors. Huh? 30.
I guess 15 to 20. 15.
15 to 20. Around 50. Around 50. But and also it is increasing because we are using more and more electric. Say, in a seat, you need 3 or 4 motors to moving front and back, and inclining, and also moving up, right? Moving up, the angle, right? And wiper is old fashion. And your mirror, and the side mirror, many, increasing, right? And then among 20,000 parts, 50 is included. The number 50 is included in 20,000, right? So there is a counting method of 20,000. But inside one electric motor, how many parts there?
50.
Right, 50 to 100, I don't know, depending on the motor. So if you break down that parts into further, it can give more, say, 200,000 or more, right? So it's depending on your, how do you manage, right? But how do you manage this? In terms of viewpoint of car maker, they purchase electric motor as a single part, right? That's why they counting is 220,000. So I'm saying that BOM tree, BOM tree of car that is prepared by car manufacturer, the parts number is around 20,000. That's why we arrived at numbers, right? So parts industry is moving on to, so if I buy 20,000 parts from parts providers, I'm a Hyundai Motors Company purchasing department, head of purchasing department. How many companies should I trade to buy 20,000 parts per car? But I have 20 different type of car is produced. And also one Sonata has different specification, right? different BOM, so that only for Sonata I should buy, as a head of purchasing department, I should buy probably 30,000 parts, different parts, right? And then we should calculate the numbers per part, right? Then how many company should I trade? Huh? 1,000? So I want to reduce down that number. Why? Many reasons, right? I cannot handle, actually, with my friends in my department, I cannot handle 2,000, 3,000 company trade. Right? Another big reason is quality issues, right? If, I should problem later, right? Small parts can create a problem, right? Quality problem that create a big accident, and then Hyundai Motors company should get all the problem. It is my own problem, right? But the parts is coming from second layer, third layer down, right? But it is assembled. So quality control, I should test 20,000 parts. But I cannot do that. So we go to the modular parts. So I may trade with probably Hyundai Motors. They have a first tier company is less than 300. Company, trading company. And then under that, there is a more, right? So it gives you sub-assembly is purchased. We call this modular. Knockdown production. Knockdown is in boxing game, right? Knockdown. Modular approach kills creativity of designer? Yes. No. Modular design kills creativity of the designer, car designer. Yes. No. What is your opinion? Huh? You don't know. Okay, let's see. What's your system? Sorry, this is a Korean language, but I explained in translate. This is a traditional way. So parts 400, parts 500, parts 300 gives you model A, model B, model C. Model A has 400 parts, model B has 500 parts, model C has 300 parts. So then you need to purchase all of them and also maintain them, storage and inside. Right? So it is old way. But now they have only 20 different modules. And combination them, module 4 gives you model AA, module 5, combination of 5 modules gives you model BB, and combination of 4 is model CC. And the purchasing department, quality control department. Here have more than 1,000 parts. Here only 20 modules. And then also you can provide more variations than this one. You can do here, but you cannot do because of this back end. Right? You can do, designers can do more variation, but it cannot be produced actually because of it cannot be handled, supported by the purchasing and by the quality and others. Right? And then also inside the modular architecture too, the baseline most important module is power module. It gives you more endurance and power, and problem comes from here, right? This is the most important module. And then they have only one kind of module among 20. it is most important one. They put many of or half of their engineering power to this module development. So it takes long time to develop new power module. It takes big money to develop a power module. But customers do not rely on this power. They don't know. Maybe they know there is a break, it doesn't work, and sometimes it is a problem, right? See, the appearance module is many, right? And functional means you have a buttons, how many buttons, how many spins, or this is functional. So it is shown to the customer. So they select from using this and gives you 85, 48. This is a real number coming from LG Electronics workshop. Right? So they separate out the marketing module from engineering module. Right? And then what is good? You can produce this baseline module many. If you sell 1 million workshop per year, if LG Electronics, then you can produce 1 million power module, same module. So you can good to economy of scale, the money, and also in terms of quality, high level quality. Right? And this one is good for customers. Right? So that is the idea. Right? Automotive modules. Also, see, seat is important for customers, right? Leather or fabric, color, right? And inclined or warming, many, right? Many variations, right? But engine, brake system, you don't know. I don't know about brake system. When you purchase your car, you don't worry about brake system, right? But it is important, right? Very important. But customers do not rely on braking. They do not check the brake system, right? So we call this is a baseline power module, right? Power module, and then additional appearance modules. So they divide into. Right, this one is also right. Car is made of upper body and platform. It's a platform. And platform is made of a powertrain, and powertrain is made of see the powertrain. This one, no. Platform is made of powertrain, chassis platform, and then the others. It says powertrain is made of engine and transmission, and this is a body, underbody. That gives you strength and suspension and gas tank, muffler, and that gives you platform. But platform is most important for engineers, but customers, they don't know. They do not know what is happening. Right? They are more concerned about color, shape, right? What is the light angle, right? And also tire, and also seat, and audio system, air conditioning. That is important. So they separate out this. So platform is evolution. Modular platform is new wording. So combination of smaller modules rather than bigger modules, smaller modules to produce platform and also variations. So they can by using this combination and separation, you can have a share the same module among different car classes. Especially you remember the LG washer module. There is only one power module, right? That is important. So reducing number of platforms by sharing same modules, that gives you increase production numbers, not size of manufacturing. And then, same again, economy of scale and quality control, right? It's good for the main part, main core part, core module. And then at the same time, you want to have a more different variations in marketing purpose, options. That is not so important for engineering or safety, right? Common platform. Sharing production facility. If you have a common platform means for the car, this is platform, right? If you're sharing production platform among different cars, then you can share also the production facility. For the say LG washer power module, they are saying, it is my guess, they produce 1 million power module. But all around the world, there are maybe more than 10 production facilities around the world, right? So you can do probably 4 or 5 factory, they really produce power module. Because you trade between transportation costs, right? It may have one China in China, one in United States, North America, one in Europe, one in India, probably, right? Where is the market is big. So mass production of common parts, that gives you economic scale. Speed up also. If you have a new car development, if you use the same platform for the next year, say Sonata 2019 is already on the sale, but production is not started yet. Maybe they started, I don't know. On the edge, right? But if you have a same platform for the Sonata 2019 and 2018, then you don't worry about this. Right? Only outside the appearance is a little bit changed. Yeah? So new car, they are saying it is new car, but the platform is the same, all the platform. Right? So they are saying this is a major upgrade. Major upgrade means probably some of the platform is changed. Major upgrade. Minor upgrade and major upgrade. Better quality. Right? New car usually have a more quality problem. But you have a same core part, engine platform, then probability of quality problem is low. Right? Claim cost. It is very expensive, claim. Right? If you have a claim is coming, it's a big damage to the car manufacturers. Right? Big damage. Also parts industry. Longer AS period than before. Because of law enforcement, every nation has new rules that after service should be 20 years something. So law, right? Then you should have all the parts available at the time, until then. Right? So you need to reduce. Japan case of AS parts inventory. 2000, same as 20 years ago. The number of cars produced inside Japan, same level. 20 years, same level. Right? Because of many reasons. One is they develop a new factory outside of Japan, similar to Korea, right? Because their salary is going up. They want to make a factory outside. Another reason is the aging society. The population is reducing actually in Japan. Total population is reducing already. So that same as 20 years. But at the same time, AS centers increased 4 times. Number of AS centers. Because of competition, because of the law, Several reasons. Anyway, this is a statistic. Because of the number of different car types increased for 20 years, right? And also low improvement of 20 years of past inventory should be maintained. Right? That is the reason of this 4 times, same number 4 times. So, and also recall cost is also sharply increased. In 20 years ago, the same problem, quality problem, there was no recall. Now, it should give you a recall, right? So, the cost is increasing. Volkswagen, modular architecture, modular platform. In old days, they have a body and platform, right? Upper body, lower platform, and then, what is it? Body and, can I read this? Platform, platform. Should be number of modules something, right? Oh, there is no modular concept here. Right. Now they changed to, today there are more modules can be shared among platform, so that they have an increase of modules about more than 60%. Common to all Volkswagen car types, not only one car. Right? That is good for them. So how can you design this car? As a designer, you should know about this modular concept, because you need to share for the new car. For the new car, you need to put more modules, more common modules here. Right? Volkswagen again. Oh, this is Volkswagen. This is Toyota, Renault, Nissan, GM, Honda. And number of platforms in 2008 and 2012, and number of car sales per platform. So they reduce number of platforms, right? Number of platforms. See, important thing is they are competing each other as a number 1 car maker around the world. Right? Volkswagen sometimes, Toyota sometimes, right? GM is going down, right? Now Renault Nissan may be the third, I don't know. But see, number of platform 3 times higher. Toyota. So that you know that Volkswagen is highly modularized, their product. Common module family, 4 plus 1 big modules. Cockpit is driving seat. Cockpit is airplane cockpit. Engine, electrical, electronic, front on the body, rear on the body. There is another division of modular concept. And shipbuilding. Did I say about ring block? This is a ship, and I chop down into 10 pieces as a fish, and then each piece is constructed outside in China or in another city, and then they carry this mega block through the barge, floating barge, into the shipyard, right? And then crane, the floating crane, hand these big blocks, mega blocks, and welding into one ship. Very fast, only 10 pieces, big, but only 10 pieces. You welding and finish. Very nice, right? This is modular architecture, right? Modular. The problem is you need to handle these all pieces, electric, piping, and other things already fixed there, already assembled there from China. Right? And then you need to only combining them at the shipyard. And productivity higher, time for construction is reduced. Good for shipbuilders. Right? But engineers, very complicated. Right? Designing and also purchasing, assembly, transportation, welding, all complicated. Right? But it's good for owner. Well, you may get higher salary because of that. Right? So you need to study more to support this modular concept. Nuclear power plant. Korea. They are saying celebration. Three-tier module, first time lifting something. 10 years ago, Samsung construction. But see, only 1,000 ton only means in shipbuilding they are saying 10,000 ton. Right? 10,000. Why? Because it is an ocean. In land side, you cannot handle this. You cannot transport this. Transportation is the biggest problem. And also crane. If you want to handle 10,000 ton crane at the site, it takes 6 months to build the crane. Right? Because it's a big hire. Right? So it is not available in land side because of transportation, because of the crane. But in ocean, you can do this. 10,000 ton blocks. So higher productivity than nuclear power plant. Airplane. Lufthansa A30, A380 is the biggest one, right? 20 is smaller. How big is it? You don't know. How many people? Cockpit module, cabin module, seat is important, and galley is a restaurant, right? Kitchen, and cargo, safety. It's a modular concept. Standard modules. This is a concept drawing. But anyway, this is similar. I have been to Boeing factory 2 years ago, Seattle. Very interesting. The floor of plant, big plant, is moving. Whole floor is moving, not conveyor belt. This is conveyor belt. And then on top, they build the airplane. So they start from the gate side. This airplane is very similar to, say, how can I say? Air base. There is a big building that hold one airplane. It's higher and wider. Right? Similar. Plant is similar. And then from the gate, they start from assembly. Right? Assembly. 1 ton of U-turn of floor is moving in this way and go out, finished. Finished. Airplane is finished. And I asked how fast is it? They are saying 1 day is 1 ton. So 1 day they can assemble this. How can you do that? Modular concept. And modules are coming from, it was Boeing. So it is, well, I know that Airbus is more modular because they do, countries are together, right? Countries are together. Boeing is mainly United States. They may have a different state. And also I found that many Japan companies provide modules to the Boeing. But Airbus is coming from Spain, Italy, Germany, England too. I don't know. Countries collaboration. So this one is a conceptual one, but it's similar. Especially the wing part is very, engine is very important. Engine is final assembly is engine assembly for the car, for the airplane. Questions? No questions. Is time correct? No. The clock is also dead again. What time is it? I should finish up another slide set.
3:26.
Huh? How many minutes we have? Only 20 minutes. Right. And then I speed up. All right. We don't have a discussion today, eh? Oh, you have a discussion. I forgot this. Okay. No. 5 minutes I finish. This is very interesting. In Japan hotel, there is business hotel. You can go to Daejeon also. Doyokon is similar to this. And the bathroom is very small and compact. And they make this as a module, and including electricity, piping, bathtub, and toilet, all together in one unit. So we call them software modules. Software modules. Standard modules. Modular architecture. Modular architecture of STEP, ISO. Plug and play. You can create a new standard by using component standard. So this is not IEC. IEC is International Electrotechnical Commission, is another big standard organization, international. They provide this site, you can visit anytime. CDD, you can check with the CDD. IEC CDD, then you can find this. There is one part. Low frequency amplifier, radio frequency amplifier. Specification. Right. Knockdown. Knockdown. IKEA? Do you know IKEA? Right? You can buy a set of any furniture. You can assemble this. Right? Car also can be created in here. Modular creativity. Skip. Okay. Question? No question. Digital twin. Because front part is almost same, so I can skip over. You already know this from the wiki. Right. What is the core technology? It was already old material. 2 years ago, AI missing, digital twin is missing, CPS is missing, 3D printing is missing, and I'm working on standard. So I put more wording on this. Also, this is another 9 technology or Industry 4.0, but I put digital twin and CPS because it was missing. And you know this Roger and this one also, even morning. This is very small car of Kia Motors you can find from the street. But the whole car manufactured not by Kia, another small company. So outsourcing of whole car. Parts, problem, Apollo, O-ring, create explosion of Apollo. How many years ago? 20 years ago, probably. 15 years ago, 20 years ago. Apollo is exploded while launching. They found why. Only one ring, O-ring, O-ring. It gives you problem. Leakage. So who make this? One small company down there. Right. Another one, Toyota. Probably 10 years ago, right, there was a big accident inside the United States. A policeman was killed. He was a driver. But he captured his voice while it happens. He is saying, brake is not working. And then, and he died. It was a big problem for Toyota. Stock price. But reason? One single spring. Pedal spring was the problem. Braking was not. So who make this spring? And what happened to Toyota? So parts is not simple. You need to have a very quality issue is there. This is another English site, so you can find more. Same Toyota problem. And this is a nuclear plant inside Korea. There was a bribe so that they escape from the test report was wrong. The false test report for the parts of nuclear power plant. So many people is jailed. Right? It's about 5 years ago inside Korea. So parts is important. Already shown this. You know this. Reshoring. They don't want to make factory inside China. Outsourcing. Now they return their factory into United States. Outsourcing, reshoring. Not made in China. Right? Speed factory. Digital transformation. Discussion. Digital twin. General Electric. Wind power. Videos of wind power and also ocean plant. So there is a twin, right? Digital and physical. Right. Tile also already showed this diagram before, right? Physical and digital. We call digital twin, but there are component technologies. Right? Definition. Deloitte consulting company. Right. Core technology, sensors and data. It is coming from Siemens, but it is timeline, real product. You start from only virtual, digital, no physical, arriving at physical. But then you can have a twin there. Operational time, twin. Here, no twin. Operation, right, because it's complex nuclear power plant, airplane, you don't know how it is operated. So you need to have a collection of operational data from using IoT. Same as, so digital twin. So in old days, 10 years ago, 5 years ago, why it is not available? Because of the cost of computing, cost of storage, and also bandwidth of wireless or telecommunication. Now it is solved by smartphone, GPU, memory chip, IoT, 5G mobile. For the video, film, you need only 3 megabytes per second. Then you can play film on your smartphone. But now they are saying gigabit PS, 5G. How many times? 300 films at one smartphone, real time. Right? Very speed. Christ work. I'll skip. Come over.
Good afternoon, everyone. My name is Hyebin Kim. I prepared the discussion. There are two topics. One is design and reducing parts and design and optimization. First topic is design and reducing parts. In modern time, as the technology develops, there are many complex machines. In general, when the machine is complex, the number of parts is increasing. But the increasing parts occur many problems. First is there is a difficulty in manufacturing and difficulty in OEM operation and maintenance, and also it caused increasing in weight. So the machine has low efficiency because of high weight. So for the complex machine, for example, aircraft, engine, robot, ship, or plant, and so on. So in assembly stage, the engineering tried to reduce the parts. So this is Jiman's video about wind turbine. It is about direct drive generator.
Having a new technology where we are in the front.
We have revolutionized the whole wind market with this new prototype that we have installed.
Yeah, even my children say that your windmill, Dad, because I've been seeing that more than them.
It is the way wind turbines will be made in the future.
동그라미 쪽으로.
어디요? 이거요?
통로.
We're there.
A lot of effort in having this prototype being built.
What makes this prototype special is that we're using a direct drive generator, so we can avoid the gearbox. It's built with fewer parts, so the maintenance would be easier.
Of course, it's a new technology from turbine business worldwide, but also for me personally, it has been a complete new thing and a new way of working in turbine business. It's a lovely turbine to work in because there's a lot of space up there, and all the parts are having an easy access to if we need to replace some of them.
We have no time, so I skip.
This is one of the most
This is a direct drive generator. Comparing with existing gearbox, in general, wind turbine use the gearbox, but the direct drive generator is proposed to eliminate the of mechanical drive component. So this is the gearbox. They use many gears, but direct drive power is only use this part. so we can remove the part. So. And this is the DFA analysis. It's designed for assembly. So to increase of efficiency of assembly, they use the analysis about assembly. So this is about motor. So they calculate the design efficiency and analyze whether the assembly is good. So this is they compare the original assembly and redesigned assembly. So how to solve the problem in CAD? The idea is that after assembly design, and CAD provides the optimized version of assembly. So there are three questions. One is the function possible in CAD system, and why do you think? And second one is to achieve the function, what technology is needed, and what limits exist. So, yes.
I have a question.
Yes.
What do you mean by simplified assembly or optimized assembly?
Yeah.
Yeah. What do you mean by the optimized assembly?
I think when we have the original, so we can assembly in CAD, and we optimized in CAD. We get the redesign.
So optimized
For
design.
yes,
Optimized.
assembly design. It can approach to part level. So
Actually, the different concern, because if you make your design modular,
yeah.
then there may be an increased number of parts in the assembly. But when there is less number of parts, then your design is less modular to some extent.
Less modular.
Like using generative design approach,
Yes.
we can create complex shapes.
Yes.
But making those shapes is difficult, expensive, and has high risk as compared to an engine that is developed by simple parts.
Anyway, in any optimization, you need to see what is the objective function. Number of parts, cost, weight, performance, depending on the objective function, is original.
The object is about this design efficiency.
So basically, just combining multiple functionalities that different parts provide into one part, something like that.
It can be.
And for that case, maybe there needs to be a clear definition of what the part of the function that the part needs to be fulfilled. Needs to fulfill.
So maybe the engineering must define the priority of assembly function.
Go ahead.
No. Any other? And second topic is design and optimization. I think it is a part level. So to improve a product, we must do optimization of part design. Its purpose is to fulfill design function and increase efficiency. For example, lightweight is one of the optimization. And in general, the topology optimization is used. 어.
알아서 다시
네.
급할 땐 저렇게 꼭 저래. 급할 땐 왜 그래?
This is the SolidWorks simulation for ice skate. And this is the MIT tool to optimize multiple parameter at once. 연결되면
이걸 넘어가면 되지. 디스커션이 안 되나? 이걸 넘어가면.
I simply explain. There are mass or length, so users can controlling the parameter, and automatically the part design is changed. So this is my subject. When I see the MIT's research, I think that the part optimization can be applied to the customization when a customer can design a product controlling the parameters of product the company provides. So it is similar to options, but I think it can be a deep level of design. So my question is, in what industry can be used and what parameter can be used at the consumer level, and any possible manufacturing problems? Yes?
Use 3D printing when we want to reduce the volume of the piece so that we have the optimal printing time?
Yeah, it is possible, I think.
I think that the personalized design case will help the consumer with this kind of thing. Like consumer can check his or her model at very basic level and can suggest a personalized product, but there can be some some restrictions with respect to manufacturing.
Yes. So the company can limit the parameter considering the manufacturing.
Maybe it can be used in research labs more than in industry because during research, if you're making a device or something and you're not sure which parameters are the optimal solution, then a user can use this to find different parameters. Maybe research is better.
And actually, this is better for manufacturing. Like the mass is reduced, the effort is reduced, number of features are reduced. So I think that to get the minimum possible material with the desired function, then it's good.
Another approach. Okay.
Different products you can make different key parameters
Maybe.
that need to be considered.
Yes. Okay. Thank you for discussing.